Hey guys, so what we're going to work on today is how to add and subtract polynomials. So in yesterday's video, which you saw today, I know that's kind of confusing, we talked about how to classify a polynomial and what that meant. So today we're actually going to start doing the math with the polynomials. So I have 8 examples that I'm going to work out with you together. There's going to be copies of notes posted on Canvas, and then you can always ask me questions in our Zoom meeting. That will be at 11 o'clock, so check your emails for those invitations. Okay, so one thing that we need to remember when we're adding and subtracting polynomials is you can only add and subtract things that are like terms. So in order for them to be like terms, they have to have the same variable to the same power. So the first thing that I would do if I were working out a problem like this is I would take everything outside of the parentheses. Just get rid of the parentheses. And since it's a plus there, you don't have to worry about changing any of these signs. You can just write everything out like it is. So I'm going to rewrite this as 5p to the second minus 3 plus 2p to the second minus 3p to the third. So all I did there was take out my parentheses and just write it like that. So now we can just focus on writing things or combining our like terms together. You want to start with your highest exponent because that's how it's going to be written. It's kind of like the proper way to write it is you want to start with the term that's the highest exponent. So if I look down the line, my highest exponent is this term right here, or my term with the highest exponent. It does not have anything else that can go with it. So when I come over here to put my answer, this is going to come first by itself because there's nothing to combine with it, okay? The second thing I'm going to look for is the squares. So I've got this term right here, and I can combine it with this term right here because they're both p squares. So if you have 5p squared plus 2p squared, that's going to give you a total of 7p squared. It's a positive 7p squared, so that's why I would put the plus there. Now, this -3, this constant, it doesn't have anything to go with it. Your constant is always going to go on the end, so I'm going to leave it as a -3 or a -3 on the end. There's nothing else you can do to that. That's in simplest form, so that would be the final answer to number 1. All right, number 2, our polynomials are 4 plus 2n to the third and 5n to the third plus 2. So again, I'm going to start by rewriting these without the parentheses. You don't have to do that step. I think it helps to see what you're actually working with if we just take them out. So a good thing about this problem is we have all positives. Don't have to worry about that. So like I said, the first thing I'm going to look for is my highest exponent, which is a 3. So I have this term that has an exponent of 3 and this term that has an exponent of 3. So I can just put those two together. So you're just going to add your coefficients. When you're combining these together, you just add the coefficients. You're not going to change the exponents at all. So 2n to the third plus 5n to the third is a total of 7n to the third. Okay, and then my last two are just these constants. So I just am going to add my 4 and my 2 together, and that's going to be a plus 6 on the end. There's nothing else I can do to that, so that's your final answer for number 2. Then the last one for number 3, it's a little bit longer. You will come in contact with some that are this long, so you just have to persevere and work it out. So the first thing I'm going to do is rewrite everything. -4k to the fourth plus 14 plus 3k to the second. Now, I'm just going to go ahead and, I know it says plus, but I'm just going to rewrite those just like it is. I'm not going to worry about that. So that's going to be minus 3k to the fourth minus 14k to the second minus 8. So all I did was just rewrite all of those without the parentheses in them. I'm going to scan through and look for my highest exponent, which is going to be to the fourth. So I have this term that has an exponent of 4, and I have this term that has an exponent of 4. You're going to combine those together by combining your coefficients together. So if I have -4k to the fourth minus 3k to the fourth, that's going to give me negative 7k to the fourth, because negative 4 minus 3 more is negative 7. So now I'm going to look through. I don't have any with an exponent of a 3, but I have a couple of terms with an exponent of a 2. So that's going to be these terms right here. So I'm going to combine those two terms together. If you have a positive 3 and a minus 14, that's going to give you a negative 11k to the second. Sorry, that's missing. And then the last thing that I have are just my constants. So that is a 14 minus 8, which combines to give you a positive 6. All right, I'm gonna pause for just a second in case you want to take a screenshot of that to use for your notes or examples when you go to work on your assignment. Let me box these answers in real quick. All right, so with the subtraction, it's the same concept, but it's a little bit more tricky because of this subtraction, okay? So what I want you to do when you see that subtraction, I want you to think that there is actually a minus 1. So when you rewrite those things without the parentheses, you want to distribute that negative 1 over this and over that term. And that's going to change the signs of the terms in that second set of parentheses. So I'm going to go ahead and write down my first term. So my first terms are a to the third power minus 2a to the second power. I don't have to worry about that. Now this parentheses, it's like saying negative 1 times 3a squared. So that's going to be negative 3a squared. I have to change the signs in my second parentheses because I'm subtracting this time. This is going to be negative 1 times negative 4a to the third, so that's actually going to become a positive 4a to the third. Now, once you've done that, you can go ahead and combine everything together like we were doing before. So for this one, I've got my a to the third right here, and I'm going to combine it with this a to the third right here. So that's 1a to the third plus 4a to the third, so that's going to be 5a to the third. And now I can just combine these two together because they're both a to the second power. So that is a minus 2a to the second, subtract 3a to the second, so that's going to be a negative 5a to the second. So the extra step when you're subtracting is that you have to rewrite that second parentheses with thinking about a negative 1 being there and how that affects the problem. So in number 5, we are going to be working with 4n minus 3n to the third minus 3n to the third plus 4n. So just taking the time to actually write that out, is going to give you the opportunity to see what this looks like with the negative there. Okay, so we've got 4n minus 3n to the third. So this is going to be like negative 1 times 3n to the third. So that's going to be another minus 3n to the third. And that is going to be a minus 4n or negative 4n. So when you combine these two things together right here, you can combine those two things together because they're like terms. That is going to be, hang on, I lost my place. Sorry. That is going to be negative 3n to the third minus 3n to the third. That's negative 6n to the third. And then what you're left with is 4n minus 4n. They cancel each other out. That's just 0. So this is going to be your final answer. You don't have to include the 0. All right, number 6. And guys, if you're doing this with me, if you're kind of following along, what you might want to do is take the time to write out number 6, hit pause on your video, and then when you're ready to work it out, just kind of work it out with me and maybe hit pause along the way to see if you're getting the right answer. So the first thing I'm going to do is write this as 4r to the third plus 3r to the fourth. Pretend like there's a negative 1 right there. Distribute that around among those two terms. So that's going to be a negative r to the fourth this is going to change to a positive 5r to the third because a negative times a negative is a positive. So now I'm going to combine my like terms together. The biggest one I have is a 4, and that's going to be these two terms right here. So when you put those two terms together, 3r to the fourth minus 1r to the fourth is 2r to the fourth. And then you can combine those two terms together. 4r to the third plus 5r to the third is going to be 9r to the third. Okay, number 7. 3x to the fourth minus 3x in one parentheses. In the other parentheses, minus, you have subtract 3x minus 3x to the fourth. So I'm going to rewrite my first set of terms right here. Now I'm going to distribute that -1 over these two terms. So this is going to become a negative 3x. And that's actually going to become a positive 3x to the fourth. Again, because a negative times a negative is a positive. So when you combine your 3x to the fourth here and your 3x to the fourth here, you end up with 6x to the fourth. And then when you combine a minus 3x, subtract 3 more x, that turns into a negative 6x. And then number 8, you will see polynomials this big that you're going to have to work with, so just do the best that you can on them. Again, if you want to take the time to copy this down and then hit pause so you can try to work it out with me and see if you get the right thing. I'm going to go and rewrite it. 3 minus 6n to the fifth minus 8n to the fourth. When you distribute that -1 all the way through, that's going to become a positive 6n, a positive 3n, and a positive 8n to the fifth. Since all those in that term are negative, they're all going to turn into positives once you combine them together. So the first thing I'm going to look for is my biggest exponent, which looks like it's going to be to the 5th power. So that's going to be this term combined with that term right there. So when you have a negative 6n to the 5th plus 8n to the 5th, that is going to give you a positive 2n to the 5th. The next thing I'm going to look for is my to the 4th power. Hang on. Oh, I copied this one wrong. Well, we're just going to go with it. Okay. I copied it wrong from the instructions. That's okay. We're just going with what we have. I don't have anything to combine with my 8n to the 4th. So that's just going to come down as a negative 8n to the 4th. I do have 2 more like terms right here. So I can combine a 6n and a 3n, and that's going to give me a positive 9n right there. And then there's nothing to go along with my 3. So that positive 3 is just going to stick there right on the end. So take a second to review these problems that I've done with you. Copy them down, try to work them out on your own, and if you have questions on anything with this or anything on the assignment, we can cover that in our Zoom meeting. For the assignment, don't be paranoid if you work it out and it tells you have a 0. Canvas is not grading that. It's just where you're going to be turning it in, and then I will actually look at it myself. When you have to put in an exponent into the text box, for example, if I was going to put this into the text box on Canvas, it's going to look like this, 2r, and you're going to type that caret symbol on your computer, and then it would be fourth like this, plus 9r and the caret symbol to 3. So that's the symbol that you use on your keyboard to designate an exponent. So that's what I'm going to be looking for when I score that. So please don't be upset or paranoid if it says you have a 0. I promise I'll go in and grade it by hand, and I'll see you guys in the Zoom meeting. Thank you.